Most poor people in the world are farmers, and many of these farmers live in sub-Saharan Africa. Improving their agricultural productivity is going to be one of the main ways we can help them get out of poverty. But to improve that agricultural productivity, we first have to measure it. And unfortunately, for most farms in the world and most farmers, their productivity is unmeasured. So that makes it really hard to target the farmers who need interventions, as well as it makes it hard to understand which interventions actually work.
Increasing productivity in small farms is one of the biggest goals we have in food security. And it's really hard to improve things if you don't measure them very well. So the exciting thing now is that with a lot of new satellites that are being put up in space, you can actually see individual fields, individual small farms around the world. And you can watch those over time as the crop develops.
There have been Earth-observing satellites up for over 3 decades now. These satellites have typically been low resolution, so 30-meter resolution satellites. And that's great for a lot of applications. It's not so great if you're trying to pick out individual farmer fields.
So if you want to be able to see a small farm around the world, you typically need something with resolution on the order of 3 to 5 meters. Historically, if you wanted to do that, you needed something like a school bus size satellite. What's happened over time is these have gotten smaller and smaller. So from a school bus size, they've gotten to basically a refrigerator size. And now even some of them are like a shoebox size. And the quality isn't quite as good as when you have the school bus, but it's nearly as good. And you have a lot more of it at a lot lower cost. So there are a bunch of companies now that are in this business of trying to develop and launch small satellites at low cost. Now that we have satellites where we clearly see the fields, the question is the data good enough? Is the data frequent enough to actually get reliable estimates of crop yield, which is our key measure of productivity in these systems?
So we are working in Western Kenya. It's one of the most intensively farmed parts of Africa. And we're working with smallholder maize farmers. So these are folks who farm typically a ½ acre or 1 acre of maize, so very, very small plots of maize. We take 2 approaches to using the satellite imagery to predict agricultural productivity yields. The first approach is to directly relate the imagery to the ground truth data that we collect through these surveys. We call that the calibrated approach. The problem is if you want to scale up our operation, you don't want to have to recollect ground survey data everywhere in the world. So we also develop another approach, which we call an uncalibrated approach, that does not depend on the ground survey data to make predictions. Instead, it uses a computer model of how crops grow to help us interpret the imagery. And just combining the imagery with that computer model of how crops grow allows us to make surprisingly accurate predictions just based on the imagery alone of actual productivity on the field.
It has really been difficult to understand what makes these systems more or less productive. And so our hope is that even though these aren't perfect measures, they're very cheap and they're good enough that it will open up a whole new way of understanding these systems.
So what we're hoping to do is to be able to scale this approach across maize growing regions in Kenya, across maize growing regions in East Africa, and hopefully across all of sub-Saharan Africa. Our aspiration is to make accurate seasonal predictions of agricultural productivity for every corner of sub-Saharan Africa.